Today I'm going to walk you through the 5-layer AI architecture stack, from the energy grid deep underground, then the chips, third cloud, fourth models, and finally fifth, apps. By the end of this video you will understand the 5 layers of the AI stack. Let us dive in. First, let's look at the scale of what is happening. A few years ago, AI was a startup game. You bought some laptops, rented some cloud space, and wrote code. That is over. In 2026, AI is about the Stargate initiative from OpenAI. This is a single project projected to cost $500 billion. To put that in perspective, that is more money than the United States spent on the entire Apollo space program to put a man on the moon, adjusted for inflation. Globally, we are spending $450 billion every single year just on physical infrastructure. We are moving from bits, software, to atoms, steel, concrete, and power plants. This is the industrialization of intelligence. If you want to understand where the world is going, don't look at the code, look at the construction sites. This brings us to the first and most critical layer of our cake: energy. Here is the dirty secret of 2026. We are running out of power. Energy has replaced silicon chips as the #1 bottleneck for AI. But why? It's because of something called the inference flip. Back in 2023, we used most of our energy training the models, teaching them. Now, in 2026, we use 66% of our energy just running them. This is happening because of the new reasoning models, like GPT-5 or DeepSeek R1. These models don't just spit out an answer instantly. They think, they pause, reason, and check their work for seconds before they reply. That thinking time costs energy. A single model class today can consume 45 gigawatt hours per day. That is the same amount of electricity needed to power 1.5 million homes. We aren't just building data centers anymore. We are building things that consume as much power as a city. So how do we keep the lights on? Well, there is the dream, and then there is the reality. The dream is green energy, but the reality for the next 3 years is what we call the gas bridge. To keep these AI brains alive 99.999% of the time, we are burning record amounts of natural gas. We are even delaying the retirement of old coal plants in places like Utah and Maryland, just to prevent the grid from collapsing. It's a messy trade-off between the future of intelligence and the climate. But the end game is nuclear. You've heard the headlines. Microsoft is restarting the 3 Mile Island nuclear plant. Google and Amazon are buying small modular reactors, or SMRs. These are factory-built mini-reactors. The tech giants are effectively becoming utility companies. They are building 500-megawatt campuses that act as negative power plants, sucking up every electron a reactor can produce. Moving up to layer 2, the chips. The engines. For a long time, Nvidia was the only game in town, and they still are the kings, with about 75% of the market. But their chips are expensive. Average selling price, $33,000 a pop. That price tag is forcing a rebellion. The big tech companies, Google, Amazon, Meta, are saying, we can't afford that. So they are building their own custom chips, called ASICs. Think of it this way. An Nvidia GPU is like a Ferrari. It can drive on any road and looks great. An ASIC is like a bullet train. It can only go on one track, but it is incredibly efficient and cheap. Google's new TPU v7 chip is doing the same work for 70% less cost than the older ways. This is the civil war of silicon. But chips are also where things get political. As of January 2026, we are living behind a silicon curtain. The US government has slapped 25% tariffs on imported chips and tightened export controls. They are trying to stop advanced AI from reaching China. This has split the world in two. On one side, you have the Western stack using Nvidia and TSMC. On the other side, you have China optimizing their own domestic chips because they can't buy the US stack. And the bottleneck isn't just the chip itself, it's the packaging. It's the glue and the wiring that connects the memory to the brain. This process is called CoWoS. CoWoS stands for chip on wafer on substrate. These are the layers of a sandwich. 1. Chip, the brain GPU, and the memory, HBM chips. 2. On wafer, these chips sit on top of a middle slice of silicon called an interposer. This is the secret sauce. It connects the chips together with tiny microscopic wires. 3. On substrate, the whole thing sits on a sturdy base layer, the green board you see in computers, to hold it all together. It is the single tightest point in the global supply chain. Layer 3 is the cloud. Think of industrial factories. We are spending $3.5 trillion on this layer. Microsoft alone is dropping $150 billion this year. The biggest change inside these factories? The air conditioning is gone. These new chips get so hot that air cannot cool them. We have to use liquid. We are dipping the computers into fluid, or running cold water pipes directly over the chips. If you walk into a modern data center in 2026, it sounds different. The roar of fans is quieter, replaced by the hum of pumps moving liquid coolant. It's plumbing, not ventilation, that keeps the AI alive. And where are these clouds being built? Increasingly, not in the US. We are seeing the rise of sovereign clouds. Countries are saying, we don't want our data living on American servers. The Middle East has pivoted hard here. Sovereign wealth funds from the Gulf deployed $66 billion into AI infrastructure in just 1 year. Saudi Arabia is building massive domestic clusters, like Project Humain. In Europe, they are building air-gapped regions, clouds that are physically disconnected from the global internet to comply with privacy laws. The internet is fracturing into national borders. Now we get to the brain. Layer 4. The models. The big shift in 2026 is from talking to thinking. We used to have System 1 models, like the early ChatGPT. You asked a question, and it instantly guessed the next word. It was fast, but it hallucinated. Now we have System 2, reasoning models. When you ask GPT-5 or DeepSeek R1 a hard question, it doesn't answer immediately. It creates a chain of thought. It talks to itself silently. It plans. It critiques its own logic. Then, 10 seconds later, it gives you the answer. This is why we need so much more energy, because quality now depends on how long you let the model think. But here is the problem. We are running out of books. We are running out of websites. We have hit the data wall. We have trained these models on basically the entire internet, and there is no more high-quality human text left. So what do? We use synthetic data. We use the smartest AI models to write textbooks for the smaller AI models to read. But this is risky. If you aren't careful, you get model collapse, where the AI starts learning from its own bad habits and turns into gibberish. This is why data quality is now a billion-dollar industry. Finally, the top layer, applications. This is where the money is actually made. And the key word for 2026 is agents. A chatbot gives you advice. An agent does the work. Look at Klarna. They launched an AI agent that handles 2/3 of their customer service chats. It's doing the work of 700 full-time humans, speaking 35 languages, and it added $40 million to their profits. We are seeing agents in supply chains that autonomously reroute trucks when a storm hits. They don't ask for permission, they just solve the problem. We are moving from co-pilots that help you type to autopilots that run the business. It's getting specialized too. We have vertical AI. Doctors now have AI agents listening to patient visits, updating medical records, and billing insurance codes automatically. And the interface is changing. It's not just typing anymore. With devices like the Apple Vision Pro, we are seeing spatial computing in factories. Engineers are walking around looking at digital twins of engines, fixing problems with hand gestures. It's Iron Man stuff, but for real industrial use. So what does this mean for you? For your job, here is the surprise. The AI boom is a blue-collar boom. Jensen Huang, the CEO of Nvidia, said it himself. We need more plumbers, electricians, and builders than we need coders right now. We are short 81,000 industrial electricians in the US. If you know how to wire a high-voltage data center, you are writing your own paycheck. 6 figures, easy. On the white-collar side, the hot jobs are agent architects, people who design these workflows, and AI ethics leads, who are making £200,000 a year just to make sure the AI doesn't break the law. It's a whole new economy. Let's tie it all together. Everything is connected. Because we want smarter models, layer 4, we need them to think longer. Because they think longer, they burn more energy. Layer 1. Because they burn more energy, we need to build nuclear plants and liquid-cooled factories, layer 3. And because we need to build those factories, we need $3.5 trillion. It is a massive feedback loop. And if any one of these layers breaks, if we run out of power, or if the chips stop coming from Taiwan, the whole tower stops growing. So what is the roadmap? Right now, 2026 to 2028, we are in the build-out. It's about natural gas, liquid cooling, and fighting for chips. Next, 2028 to 2030, the nuclear plants come online. The reasoning models become standard. The future, 2030 plus, the autonomous enterprise. This is where agents run the core functions of companies, and nuclear SMRs power the grid. We are building the physical foundation for a new kind of civilization. Here is the bottom line. For the last 20 years, Silicon Valley told us that software would eat the world. They were wrong. AI is eating the physical world. It's eating energy. It's eating copper. It's eating steel. If you want to win in the next decade, don't just look at the algorithms. Look at the infrastructure. The winners will be the ones who control the power, the chips, and the physical means of intelligence production. Thanks for watching. Don't forget to like, share, and subscribe to the AI with Arun show. We will be back soon.